Hey Panthers! We have our official last video of the year. We are going to take a look at section 5.9 again, but we're going to look at what happens to the perimeter and the area of shapes when they are either enlarged or reduced. So we've talked in class about reductions and enlargements. And we've taken a look at scale factor. Scale factor tells you how many times something is enlarged or reduced. And what we're going to focus on today is what happens to the perimeter and the area of those shapes after they've been enlarged. And again, remember on your cartoon drawing, question number 1, what is the scale factor? After this video, I'd like you to take a look at the boxes for your cartoon drawing and see if you can guess what the scale factor is. In other words, the cartoon you started with, how many times was it enlarged on your sheet of paper? So we have 2 definitions here and 3 rules to remember. First of all, the scale factor is the ratio of the original and new dimensions. We already know that. It's the same as, remember, model over actual. Okay. And our second term here, dilation, is a proportional reduction or enlargement of a figure. A reduction meaning it becomes smaller, and again, that's proportional. If you're looking at your cartoon, if your hand is on your cartoon is 3 times smaller, your head is 3 times smaller, and your eyeball has to be 3 times smaller, and your fingernail has to be 3 times smaller. Every part of your drawing has to be smaller to the same degree. Or you could have a dilation that's an enlargement, and this would be that your picture gets larger, and again it happens proportionally. So if your wrist is 5 times larger, your nose has to be 5 times larger, and your feet have to be 5 times larger, and so forth. 3 rules that I would like you to follow. The scale factor is less than 1. We've talked about this. If your scale factor is less than 1, the dilation will produce a reduction. And if the scale factor is greater than 1, the dilation will produce an enlargement. Remember that from class. If your scale factor is less than 1, it will produce a reduction, and if the scale factor is greater than 1, it will produce an enlargement. Rule number 2. The ratio of the perimeters of 2 similar figures is equal to the ratio of the side lengths. The ratio of the perimeters of the 2 similar figures is equal to the ratio of the side lengths. That ratio is the scale factor. So here's what this is saying. If you took the perimeter of your enlargement or your reduction and placed it over the perimeter of your original enlargement or your original shape, that would also give you the scale factor. In other words, the ratio of the perimeters equals the ratio of the side lengths. We'll see that in just a second. And rule number 3. The ratio of areas of 2 similar figures is the square of the scale factor. The ratio of areas of 2 similar figures is the square of the scale factor. Here's what I would like you to write next to rule number 2 and rule number 3. If you start with the perimeter of your original and you multiply it by the scale factor, it will give you your dilation. That may be an enlargement or a reduction. For the area, if you take the area of your original and multiply it by the scale factor squared. So whatever your scale factor is, multiply it by itself. This will give you the area of your dilation. Let's show you what this is talking about. For example 1, all I want you to do is take a look at the scale factors and determine if it will produce a reduction or an enlargement. And again, you determine that by, if the scale factor is greater than 1, it will produce an enlargement. And if it's less than 1, it will produce a reduction. So letter A. Is this less than 1 or greater than 1? Please write this out. It is less than 1, therefore it is a reduction. You're taking your original and you are shrinking it down proportionally. Letter B, greater than or less than 1. It is greater than 1, and therefore it produces an enlargement. In other words, your original, you are going to enlarge your original 1.5 times. Because 3 over 2 simplifies to 1.5. And letter C, our scale factor is 1 over 2, 1 to 2. This is greater than or less than 1. This is less than 1, just like a half. 1 to 2. Less than 1, and therefore this would also be a reduction. So part of your practice in class tomorrow will be, given these scale factors, if it's greater than 1, it is an enlargement. If your scale factor is less than 1, it is a reduction. And then the second part. Example 2, find the perimeter and area of each polygon after the given dilation. Couple things you need to know here. The scale factor, you need to know the original perimeter and the original area. Okay? Here's what happens. If you go back to the formula as I said earlier, let's start with perimeter. This is our original shape. Okay? This is the original. This is our actual. What I want to do is apply a 3:1 scale factor. In other words, I want to take this rectangle and enlarge it how many times? 3 times. 3:1 is 3. And again, 3 is greater than 1, therefore I'm trying to enlarge this. Let's start with our perimeter. To get our new perimeter, you take your original perimeter, which here is P, and you multiply it by your scale factor, and I'm going to just abbreviate SF. You take your original perimeter, which is 82, and multiply it by your scale factor. Our scale factor again is 3:1. This will give you the new perimeter to your model shape, your new shape. So 82 times 3, you're going to get 246, and the units should stay the same. These are in centimeters, and so these will also be in centimeters. So this is saying if the perimeter from my original rectangle is 82 centimeters, if I were to enlarge in this 3 times, my new perimeter for my shape will be 246 centimeters. Okay, getting quite a bit larger. Let's take a look at area. Remember, for area, you take the area of your original shape, so this rectangle, which is 390, and you're going to multiply it by the scale factor squared. Scale factor squared. What's the scale factor again? 3. So you're going to take 390 and multiply it by 3 squared, which is what? 3 times 3 is? 9. So 390 times 9 equals 3,510. And again, what are our units? Square centimeters. Square centimeters. Remember, whenever you're dealing with area, your units are always going to be squared because you're multiplying two dimensions. You're doing length times width. You're multiplying two dimensions. Your units are always squared. So once again, what this is saying is if I take the area of my original rectangle, which is 390 square centimeters, and multiply it by my scale factor squared, so 3 squared, it will give me the area of my new rectangle after it has been enlarged 3 times. Let's take a look at B. For B, again, we'll start with the perimeter. To find the new perimeter, you take the original perimeter and multiply it by the scale factor. So our original perimeter was 34, and our scale factor is 1 to 2, which is like 1/2. So 34 times 1/2 will give you 17, and our units are inches. Perimeter is a one-dimensional analysis because you're not multiplying two things together. So you notice the units are not squared. And to find the area, you multiply the original area by the scale factor squared. Let's plug in what we know. The original area is 54 multiplied by the scale factor squared. That would be 1/2 squared, and if you were to multiply that out, you would get, grab your calculators, 13.5. And again, our units are square inches. Again, anytime you deal with area, your units are always squared. Okay. Last one, Panthers. Home stretch, here we go, example number 3. A postage stamp has a perimeter of 3 3/4 inches, and let's go ahead and write that. P is 3 3/4 inches, and an area of 7/8 square inches. Find the perimeter and the area of a scale drawing of this stamp if the scale factor is 8. Now the scale factor is greater than 1. Is this going to be an enlargement or a reduction? It's an enlargement. It's greater than 1. How many times is it being enlarged? 8 whole times. So once again, go back to our formulas. To find the perimeter, you take your original perimeter, which is 3 3/4, and multiply it by the scale factor. In this case, which is 8. 3 3/4 multiplied by 8, you get 30. What are our units? 30 inches. And for the area, you take the original area and multiply it by the scale factor squared. Why for area? Area finds the measurements for 2 dimensions. So it's going to be length times width. It's going to be squared. So we start with our area, which we know is 7/8 inches, multiplied by scale factor squared. So that's 8 squared, which is what? 64. 8 times 8. Multiply it, and you should get, on your calculator, 56. What are our inches of our original area? Square inches. And you are done. One last joke for you, Panthers. What occurs once in every minute, twice in every moment, and yet never in 1,000 years? See me for the answers. Have a good night.